and 10, 11, and 12. Now, I promised you on the test, as you have it on your number strip, I'll give you 2 points. I promised you on the test you wouldn't have to graph polynomials that were degree what or higher? 5 or higher. 3 said it first, they get 2 points. So, which of these math workshop problems would not make the test then? Kelsey, you get a point. Not Kelsey, it's Mackenzie. It was you, right? It was Mackenzie. Okay, so 10's not on the test, and the reason is its degree is too high. Okay, and then tell me what else is not on the test.
11, 12.
Why is 12 not on the test?
Because it isn't the same. Because it's exactly the same.
Okay, they're both way too high of degrees. So 10 and 12, while we're going to practice them now because they're good skills to have, they're literally not on the test because, well, I'm not saying I won't ask you to state the degree, sign, leading coefficient, but I'm not going to ask you to graph. Again, I promise you, no graphing 5 or higher without getting your graphing calculator back. Okay, let's start off with number 12, actually. Let's go completely out of order. It wants to know the zeros. So where are my zeros? 1, and every group can have 1 point. I need to know the degree and the leading coefficient.
The degree is 5.
And Arturo's group gets a point. 3, 4, 5 is correct. 3, 4, 5. 3 plus 1 plus 1 is 5. And the leading coefficient we assume is a positive 1. Mackenzie, your group gets another point. Okay. So I'm going to put my zeros at 2, 1, and negative 1. Because my degree is 5, should I have in behavior that goes opposite directions or in behavior that goes the same direction? Are they both going down, or is one going down, one going up?
One's going down, the other's going up.
Yes. 2, the opposite of negative 2 is positive 2, the opposite of negative 1 is positive 1, the opposite of positive 1 is negative 1.
Not with the leading coefficient.
If we were to work this all the way out, there's a plus 1 in front right now, and it's going to stay a plus 1. Well, really, we're not even worried about the number. We're really worried about the sign. And I know since it's a positive out front, it's a positive over here. And all that's really helping me think about is that end behavior. Because Arturo's right. Because the degree is 5, the end behavior is opposite directions. Not the same direction. They got to be opposite directions. Since it's an odd degree. But since the leading coefficient is positive, I want a snake up in the wall.
Yeah, because it would start negative, then it would go up top. Because it would start negative and go up positive.
Right. So again, since the degree is 5, I know my end behaviors are opposite. And then since it's a positive leading coefficient, my snake's going up the wall. So I'm going to start down here and make my snake go up the wall. Do I have any multiplicities that I should worry about before I keep connecting the dots like I am somebody? This one, the negative 1, has a multiplicity of 3. Thank you, 4. I would have given it to you, Dave, but you said 1. We discussed the other day it has a multiplicity that's not an even one. It doesn't do anything cool. Only the even ones end up where it's like a bounce there, where it makes like a parabola there. So even though there is a multiplicity of 3, it's not going to make our graph cool in any way. So literally, I'm just trying to connect the dots and make sure my end behaviors are opposite. Now, since the degree is 5, does it have to look exactly like that snake? No. It might look more like this. Well, I didn't do a good job on that because it can't cross there. I mean, it has to cross at my set zeros. My gosh, Miss Compton. I can't make up new zeros. Come on, whiteout. Work now. Okay. So it might not look that cool, but it might have a few more humps in it than what we originally drew. Just because the degree is 5, it might look a little more of a fancier snake. I don't really know. I would have to confirm that with my graphing calculator. Again, that's why degree 5 or higher, you would get your graphing calculator in real life. Are there any questions about are about number 12. Any of the things we did on number 12. That entire list and thinking through how to make our graph, that is on the test. Okay, then let's go to number 10 and we'll save the easy one for last. Number 10. I need to know where are my zeros. And you're not done. And 0. 6 and 2 get a point. And that's what's going to happen on the test. So I'm really glad Eduardo made that mistake. Yes, 4. Yes, -2. Yes, -3. Don't forget about that x over here. That means there's a 0 at 0. Okay, so I'm going to go ahead and put my point 0, -2, -3, +4. Okay, are there any, before we move on to the next part of the list, are there any multiplicities I need to worry about? I see a multiplicity of 2 at what numbers?
4 and 3.
Multiplicity of 2 at 4 and -3.
And a multiplicity of 3 at -2.
Multiplicity of 3 at -2. Multiplicity of 2, I drew arrows. So the multiplicity of 2 is where we have a cool parabola. So that's going to be important for us in a second. So yes, these two, because the exponent of 2 had a multiplicity of 2. This one, because the exponent of 3 had a multiplicity of 3. Okay, so we still need to know the degree and the leading coefficient. The degree is what? Yes, ma'am, and you get 2 points for that. 3, 4, 5, 6, 7, and there's 1 there, so 3, 4, 5, 6, 7, 8. The leading coefficient, what is the leading coefficient? Positive what? Positive 2. 1 and 2 get a point. 3, did you say that as well? Okay, that's what I thought. You can have a point. Okay, so since we have an even degree and a positive leading coefficient, are both my ends going to be facing up to heaven? Or both my ends going to be facing down to hell? Up. So I know I'm going to end up looking like this. At the end, it's going to be an up. At the end, it's going to be an up. Now, I'm going to question mark some of the stuff in the middle, but at those ends, I'm going to do that. Since at 4, we have a multiplicity of 2, I know there has to be like a parabola at 4. Some of us missed this part on our checkpoint and got sent back for that. Don't forget about the multiplicity. If it's an even multiplicity, we need to have a little hump there. We still have an even multiplicity at -3. Yep, so I still need to do a little hump at -3. Was that -2? Thank you, dear. I'm telling you. And you can have a point for that. Bless you for paying attention to me. Someone needs to watch me. Okay, so he's right. That looks much better. That looks much better. And then there's a point there. I'm just making it uglier and uglier. Okay, the stuff in between you and I are guessing on, but no one else gets to have the cool humps because no one else has the even multiplicity. So maybe it just goes straight down through. Maybe it went up. Maybe it went straight down. Maybe it does this. I don't really know. Again, if it's that high of a degree 8, you get to graph it in your calculator. The things I know for sure are that both ends are up because of the positive leading coefficient and the fact that it's an even degree. And I also know that there are humps at those 2 spots because those 2 spots have a multiplicity of 2. The middle bit, I can forgive Arturo for. Okay, are there any questions about 10 or 12? Then we're going to deal with 11, which looks harder. It's actually the easiest. Why is it the easiest? Why is it the easiest? They are all even. She is on to what we're going to do in just a second, so I'll give her a point for that. It's easiest because the degree is 2, and the leading coefficient is a -2. So I already know it's a what shape? Give me an alphabet letter. if it's one more person tells me W or M on degree 2 and not degree 4, I don't know what I'm going to do. I think I might get degree 4's tattooed to my arm or something. It's either a U or an N. It's either a happy face or a sad face because degree 2 is parabola. It's a sad face because of that negative leading coefficient, so it's more like an N. So I hadn't even figured out where the zeros are happening, but I know it's going to look just like that. So that's why this one is the easiest, because I already know exactly what the graph should look like. Okay, Natalie was right. We need to know those zeros, and in order to do so, we're going to have to factor. Let's pull out that negative 2. She was correct with that. If we pull out that negative 2, we're left with x squared plus 6x plus 8. Can I factor that? Yes, ma'am, and you get your point for that. 4 and 2. 4 plus 2 is 6. 4 times 2 is 8. And yay, thanks to Kelsey's excellent factoring, I now know my zeros. Where are my zeros?
-4, -2.
Okay, perfect. So at -4, 1, 2, 3, 4, and -2, I know I crossed the x-axis. And again, we already know because the degree is 2 and leading coefficient is negative, I know it's that sad face parabola or an N shape. So yay, I'm already done. That one ended up being the easiest, and we had factor. Okay, so again, half the test is, can you do this? Can you figure out, given a polynomial, how to make a basic sketch of the graph? The other half of the test is what we're talking about today and tomorrow, which is the first page of your new packet. I swear we're not doing the whole packet for the new test. I don't know why we're only doing the first page. The first page is what's going to be the next thing on the last part of the next test. So you got this giant packet, and we only want to talk about the first page. So we just talked about factoring. Factoring had to help us get to those zeros because sometimes we don't know where those zeros occur. And so no wonder we're going to talk about factoring and solving equations because that still helps us get to these zeros. Okay, so I can't read whatever's at the top, but I know it says, remember, you cannot factor until the equation is set equal to 3 and who was the other one? 6, good point. Okay, so we're good on 1, 2, 3, 4. They're already set equal to 0. What's the first problem we're gonna? Which problem should we have trouble with? Because it's not set equal to 0. 5 is gonna be an issue. You get a point for that. 8 is gonna be an issue. You get a point for that. 11 is gonna be an issue, and you get another point for that. Lord, he just racked up on points because he paid attention. They weren't set equal to 0, so we're gonna have to pay attention to 5, 8, and 11. Good. Very good. Okay, so let's go back up to the top. Back up to that top. And now I've got to know, because it's going to drive me wild, what is that number that is cut off? I assume it's x squared, but Lord, it helps to check to make sure. It is x squared minus 9. So where your hole punch happened, my bad. It's supposed to be x squared minus 9 equal to 0. This one is an easy one. You got this. Can we factor that? It's the difference of perfect squares. So what should I put? Yes, 0, and you get a point for that. And then I'm sorry, but there's no point in factoring if we're not going to go ahead and list those zeros. The whole point in factoring is to help us get those zeros for the graph. So where are my zeros? Yes. 1 and 2. I know I heard you. If anyone else said it, you can have your point. We're going to come back to number 2. We're going to skip it for the moment. Why are we skipping number 2?
Because it's almost exactly the same, but it's positive.
And that sadly is an issue. That sadly is going to be an issue. We're going to have to pull out some special tricks for that. Let's go to 3. We'll save 2 for a second. Let's go to 3. What can we do on number 3? 3 what? Yes, Sarah, you can have a point for that. If we pull out a 3x, we're left with
X plus 3. X minus 3.
3x squared minus 9x. That's correct, Arturo. So where are my zeros then?
3, -3.
Say it again.
0 and positive.
Okay. You can have your point.
Why wouldn't you put -3?
It's the opposite signs. It's like I did.
Why don't number 1 put 3?
I went out of order because you went out of order. It's like I set each of these equal to 0, so I do x plus 3 equal to 0, and I do x minus 3 equal to 0, and so I get x equals -3, and I get x equals positive 3. So it just worked out on that one. So if we did the same sort of logic on ours, 3x equals 0, I get x equals 0, x minus 3 equals 0, I get x equals positive 3. Yes, dear. Let's just continue to skip it for the moment. Humor me. Humor me. It's Monday. Okay, is everyone good on number 3 now? Let's go to 4. It is another good one. It is a really good one. I can do it easy. Or at least so I think I can.
If you take out 4,
It looks like the difference in perfect squares, except for that exponent of a 4, so we're going to have to deal with it in some way.
5.
I heard the 2, I heard the 5, but someone put words together and helped me put stuff into the 2 terms.
X plus 5.
One of them's going to be a plus 5,
2.
and one of them's going to be a minus 5. And there's a 2, and there's an x squared, and there's a 2, and there's an x squared. Yes, thank you. Between the 2 of you, we got it. So 1 and 2 get a point. The square root of 4 is 2, hence the 2 2's. The square root of 25 is 5, hence the opposite signs on the 5's. If you don't believe me and you want to FOIL this out, you could and check yourself. However, we're not done. We need some final answers. We need some final answers. Darn it for me an x to the 4th. If it was just an x squared, we'd be done. We would say 2x minus 5 equals 0, and then we would solve and call it a day and go to our happy place and life would be grand.
You got to square root it.
We're going to end up having to do that, yeah. So sadly enough, we're going to have to set each of these equal to 0. So I'm going to do 2x squared minus 5 equal to 0. And 2x squared plus 5 equal to 0. So if I start solving this equation, I've got 2x squared equals 5. X squared equals 5 over 2. And what do I do to get x by itself? What operation do? I need that x squared to be an x. What am I going to have to do? I want to get rid of the squared. How do you get rid of the squared? Take the square root. Well, Miss Brister's been saying it for 5 minutes, so I'm going to give Miss Brister the point. Oh, wait, she doesn't have to get points.
No, I said it. I said you have to do it. She didn't tell me.
Oh, okay. It's up to Brister. So I'm going to get x equals plus or minus the square root of 5 over 2. Can I simplify that square root in any way? Is 5 a perfect square? Is 2 a perfect square? Then we're good. That's as good as it's going to get. Now, does that stink? Yes. Would we get our calculator to figure out exactly where those decimals are? Yes. But since we are, and I know you're like, Miss Compton, are you serious? But since we're a 4, I was anticipating 4 zeros. We found 2 of them. I'm expecting to find the other 2 by solving this second equation. So if we had to make a list of zeros, right now I've got one at positive square root of 5 over 2, and I've got one at negative square root of 5 over 2. Okay, I need to solve this second equation as well. So I move over the 5. I divide by 2. I take the square root. But I'm not done on that one. Why? Yes? Yes? So what do I need to rewrite that as? Well, yes, yes. Okay, 4, 3, and 6 get a point. So I'm going to change that to plus or minus square root of 5 over 2, and then I'm going to put the I on the end. Literally have to get rid of that negative under the radical. That's why we talked about I. So again, in my list of zeros, I've got positive square root of 5 over 2, negative square root of 5 over 2. I've got positive square root of 5 over 2I, and negative square root of 5 over 2I. Yes, our graph has 4 zeros because it is x to the 4th. But only 2 of those are real zeros. The ones with I are called imaginary zeros. For 3 points, because you don't remember, but it would just make my whole day if you did. For 3 points, can you tell me what the deal is with those imaginary roots on the graph? Do we cross the x-axis with the imaginary numbers? We don't. If we were to graph this right now, which maybe I will, because haha, I still have graphing. If we were to graph y equals 4x squared minus 25 right now, which we don't get to on the next test because that's cheating, but if we were to graph it, you'd be surprised it only crossed twice. Why did it only cross twice? It only crossed at positive square root of 5 over 2 and negative square root of 5 over 2. The imaginary ones, it doesn't cross the x-axis there. They're imaginary. Yeah, I for imaginary. The imaginary numbers. So, literally, those things won't be seen on the x-axis. Because the x-axis is real numbers. 1, 2, 3, 4, 5. Those are real, legit numbers. Those are not. So, why would it cross the x-axis? They're not the same. I know I want too much from you sometimes. Okay, let's go back to the one we've been skipping. Let's go back to number 2. How to factor number 2. How can we factor this? Can we factor this? Do you know how to factor this? I don't know how to factor that. Do you know how to factor this? The only thing I know to do is to solve. But if I solve it, and I take the square root of both sides, I'm going to get x equals plus or minus something. 3 what? 3i. I know the square root of 9 is 3. I've got to deal with that negative, so it's 3i. So if I were to graph this one on my graphing calculator, which I'm going to type in right now, should I expect it to cross the x-axis? No. If it's an I, it's not going to cross it. I graphed it, and I got real sad. Look, my parabola is so far to the top of my screen, it's nowhere near that x-axis. It does not cross it at all because we got imaginary roots. Those are not real roots. Those are roots, but they're imaginary. So we're not going to cross that real x-axis. It's not going to happen. Okay, we're going to call it on that. Oh my goodness, at the amount of people who have not shown me their graphing homework, their maze, they got a 0, 4, all the things. If you've not shown me one of the things, you have 4 minutes. Jesus, take the will, get your last day.